corner of your screen. This works like a chat. This webinar will be recorded and it will be posted to our Earthdata Adobe Connect catalog. The URL will be provided on the contact slide at the end. All presentation files will be available for download at the end of the webinar. The webinar itself is 1 hour long. We have 45 minutes that are allocated to the presentation and live demonstration portion of the webinar, and then 15 minutes for the question and answer period. So after the speakers have finished their presentations, what we will do is we will move to the final set of polling questions. The question and answer period will follow after the final set of polling questions. As I mentioned earlier, you do have an opportunity to ask your questions throughout all portions of the webinar, with the exception of the live demonstration by using the Q&A pod in the lower right-hand corner. And this works like a chat, so you would just enter your question or concern in there. Due to the large number of participants, questions will not be answered using the raising hand function that has been disabled. We will take all questions verbally at the end. One final note, depending upon the volume of questions that we receive, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who would wish to stay on the line. So let's move next to the agenda. And for those of you who are listening to audio by way of your computer, if you could type into the Q&A pod that you can hear me fine, that would be fantastic and very helpful for an audio check. Okay, so as you can see here on the agenda, during the first 15 minutes, our first speaker will provide you with an introduction to the Langley DAAC, the data center disciplines, and the data holdings. During the next 20 minutes or so, our second speaker will take you on a brief tour of the Atmospheric Science Data Center website, and will then go through a step-by-step live demonstration or workflow to identify, access, visualize, and order test data. It is my pleasure to introduce our first speaker today, Michelle, who is a User Services Analyst at the Langley Distributed Active Archive Center. Michelle?
Thank you, Jennifer. Before I get started, I'd like to let you know I do have a cold, so please bear with me if you hear my voice crack or you hear me coughing. Okay, let's get started. Welcome, everyone. I will be your co-host on your journey through the NASA Langley Research ASDC webinar. But first, I'd like to tell you a little bit about myself. I've spent most of my 37-year career at NASA Langley Research ASDC. I started as a computer tape librarian, then I moved on to become a system administrator for PC and Mac systems. I served as a company liaison for a computer subcontracting company and worked in a computer operations for ASDC. Presently, I am a part of the User Services team where I've been for 6 years. NASA Earth Observing System Data and Information System is a key core capability in NASA's Earth Observing System program. It provides end-to-end capabilities for managing NASA's Earth science data from various sources like satellites, aircraft, field measurements, and various other programs. On our next slide, we'd like to show where our discipline-oriented data centers are located. Within EOSDIS, there are 12 discipline-specific distributed active archive centers that process, manage, archive, and distribute a variety of Earth system science data. The ASDC DAAC is one of these 12, and we are located here at Langley in Hampton, Virginia. The data we receive are stored and or are processed in various environments and formats. Excuse me. The data we distribute are free and available for use to the scientific community, teachers, students, and the general public. Our next slide will provide some quick numbers about what's being done at ASDC. The ASDC has an extremely heterogeneous collection of data, synergistic disciplines that can help understand and model the climate chemistry connection in our Earth systems. Also, we have an extensive collection of aircraft holdings that complement and supplement satellite data. This is a picture from 2012 of John Custerer, the head of ASDC, standing in the middle of the data tape drives, which represents only a fraction of the numbers mentioned. Now let's move on to the next slide about Earth science disciplines. The ASDC have 4 key science disciplines: radiation budget, cloud, aerosols, and tropospheric chemistry. Within each discipline, there are projects that contain a collection of data that are applicable to one or more disciplines. So let's move to the next slide to talk about radiation budget. Within radiation budget, the featured products are series. The series missions are a follow-on to the successful Earth Radiation Budget Experiment mission. Series data were collected from instruments on board TRIM, Terra, and Aqua satellites. The newest series instrument was launched on board the Tsunami National Polar Orbiting Partnership, NPP satellite. Series data are available from December 27, 1997 to the present. IRBI. The IRBI measurements were collected from 3 satellites, IRBS, NOAA 9, and NOAA 10. IRBI data are available from November 5, 1984 to March 12, 2003. SSE and SRB data are assimilated and reformatted data sets that arrive from primary inputs from ISKIP, NOAA's Climate Prediction Center, and series flash flux modus instruments. SSE data are available from July 1, 1983 to June 2005, and SRB data are available from July 1, 1983 to December 31, 2007. ISKIP data are collected from the suite of weather satellites operated by several nations and processed by several groups and government agencies, laboratories, and universities. ISKIP data are available from July 1, 1983 to December 31, 2009. On our next slide, we will talk about clouds. You can see there are 2 projects, ISKIP and SERIES, that were also a part of the radiation budget. This is a good example of projects that provide data to more than one discipline. So I will just talk about the Calypso and MISR products. Calypso measurements are collected from the Cloud, Aerosol, LIDAR, and Infrared Pathfinder satellite observation, which was launched on April 28, 2006. And Calypso data are available from June 13, 2006 to the present. MISR, or the Multi-Angle Imaging Spectroradiometer, was NASA's first Earth-observing system spacecraft, launched on December 18, 1999. MISR data are available from March 1, 2000 to the present. On our next slide, the primary projects for Aerosols are Calypso, MISR, and AirMISPI. We previously covered the Calypso and MISR personalities, so let's look at AirMISPI. AirMISPI data are collected from the Airborne Multi-Angle Spectropolarimetric Imager instrument, which flies on the NASA-owned ER-2 aircraft. AirMISPI data are available from August 1, 2013 to September 23, 2013. On our next slide, we will talk about Tropospheric Chemistry, which features the TESS and MOPIT projects. TESS, or the Tropospheric Emission Spectrometer data, are collected from the TESS instrument, which launched into orbit aboard the AURA spacecraft on July 15, 2004. Excuse me. The AURA spacecraft is a part of the A-Train constellation of satellites. TESS data are available from August 22, 2004 to the present. MOPIT, or the measurements of pollution in the troposphere data, are collected from the MOPIT instrument aboard the Terra satellite. MOPIT data are available from March 3, 2000 to the present. On our next slide of featured projects shows ASDC's most popular projects which support the Earth science disciplines. These projects provide a wide range of data that are available to the public from ASDC's EOS website. The next slide features a short animation with NASA's current satellite fleet. I thought it would be good if you could see where our satellite data is coming from. This gives you an idea of the orbit and coverage of these platforms. Our newest satellite, GPM, or the Global Precipitation Measurement Mission, a partnership between NASA and JAXA, launched on February 27, 2014, and has been added to this animation. It will feature increased resolution and coverage over the Tropical Rainfall Measurement Mission, which is TRIM. Since I will mention our key Earth-observing satellites later, note the Terra platform, the flagship satellite for NASA's EOS satellites, launched in December 1999. Terra is the first Earth-observing system platform and provides global data on the state of the atmosphere, land, and ocean, as well as their interactions with solar radiation, and with one another, which crosses the equator at the same time daily at 10:30 a.m. The next is Aqua, launched in 2002, crossing the equator at the same time daily at 1:30 p.m., with instruments aboard that are taking measurements for Earth's water. The third in the fleet, Aura, launching in 2004 with instruments aboard that measure atmospheric parameters. Aqua and Aura are also a part of our A-Train, or afternoon constellations, Calypso and CloudSat. You can also see our A-Train constellation, Aqua, Calypso, CloudSat, and Aura. And finally, Aquarius, measuring sea surface salinity. Now, let's move back to the presentation. On our next slide is an image captured by Series Sensor, which shows where the hot and cool temperatures are located across the country. The bright yellow are the hottest temperatures, and the blue and white colors indicate cooler temperatures. On the next slide shows images created by Series FM5 on the Suomi National Polar Orbiting Partnership NPP satellite. Here, you can see how the light-colored clouds on the left side, which is incoming energy, correlate with the blue areas, which is outgoing energy, on the right side of the image. Now, just try to visualize for a moment that if you laid the right image on top of the left image, they fit together almost perfectly. On the next slide, The MISER instrument captures an erupting volcano. On the left side, you can see the dark round spot on the upper right side of the image, and that is the volcano before the eruption. On the right side, that dark spot becomes bright red and orange to indicate the eruption of the volcano. And at this point, the plume height is measured to see how much ash is injected into the stratosphere. On our next slide, we would like to mention a few of our popular projects, SSE, AirMISTY, and My NASA Data. SSE datasets contain parameters formulated for assessing and designing renewable energy systems. Also, SSE data is formulated from NASA's satellite and reanalysis derived installation and meteorological data for the 22-year period July 1983 through June 2005. My NASA Data, or MND, is a tool that allows anyone to make use of satellite data that was previously unavailable. Through the use of MND's live access server, a multitude of charts, plots, and graphs can be generated using a wide variety of constraints. Now, this concludes my portion of the webinar. Thank you, everyone. Jennifer?
Okay, thank you, Michelle. We will now move to the live demonstration portion of the webinar, and our next speaker is Jane Saddington, who is a User Services Support Scientist at the Langley DAAC. Mary Jane?
Thanks, Jennifer and Michelle. I'm Mary Jane Saddington, and I'm delighted to share this live demo portion of the webinar. A little about myself. I'm fairly new to NASA and the ASDC. I've only been here about 3.5 years. Beyond that, I have over 25 years of experience working with geological and geophysical data as a geologist, geophysicist, database administrator, and systems analyst. Most of that time was spent in the area of customer support or user services. So you should be looking right now at a little outline slide of what I'll be going over, called Working with ASDC Data. First, I'll have an overview of our homepage, and then I'll go through an example workflow of acquiring and downloading and visualizing test data. So now I'll be sharing with you my screen, or a portion of my screen. You should be looking at the ASDC homepage. I'd like you to look very first at the top portion called NASA Earthdata. If you look across the top, this will actually take you away from our website to the Earthdata portion of NASA. And for example, if you go to data centers, those are links to other of the DAACs. Data discovery gives you other options for finding other data and other programs. Over here to the top right is a search window, and that searches the ASDC website. So for example, if I typed in Calypso, it would bring up some options where you could just click on it and go to the Calypso area of our website. There's two hover areas. If you hover over the Data Descriptions tab, you'll see a list of our various projects in the scientific discipline categories. So I could click on one of those and could go directly there. If I click on Data Descriptions, that pins that to the window temporarily. And again, you can select any of these, and these are links that would take you to those project pages. Another hover area is Help and Resources. The same thing. If you hover over it, it brings up a list that you can select from, or you can click on it and it will bring up that, it will pin that to your Windows temporarily. Two areas I'd like to look at here. The first one is tools. There are some project-specific tools. These are programs that were written to help you utilize those various data, Calypso, Moppet, Miser, Sage, Moppet, and some other tools. But what I really want to show you here is the HDF and HDF EOS tools and information. These tools are made by the HDF group, which was a consortium put together by NASA to develop tools for the HDF files. And what are the HDF files? Almost all the data in the ASDC are formatted in HDF format, one or more formats. There are various HDF4, HDF5, HDF5 EOS, and excuse me, the HDF group has written various software and other programs to let you look at the data and use the data. And we will actually be seeing HDF View a little bit later on. The other portions here, players, viewers, and plugins, those are more just typical software programs like Java Runtime, Microsoft Viewers. If you look to the left-hand side, under these disciplines, if you click on any one of those tabs, it will bring up the projects in alpha. Okay, we've had a little blip here. Something has happened in my window. Okay. So you should be looking at aerosols. I clicked on aerosols, and you can see the 3 pages of aerosol project data. They're listed in alphabetical order, and you have spatial coverage and temporal coverage, and you have more information about each project.
Mary Jane, we are not seeing that.
You are not seeing that. Okay.
Stand by.
Okay.
Thank you.
That was weird. Okay, let's see. Let me go to... I'm trying to find my... Oh, okay, yeah. Here we go. I'm going to try sharing my desktop since we had that little blip. So now are you seeing my Firefox window and the aerosols? Jennifer?
Yes.
Okay. All right, so we'll go this way then. So anyway, I clicked on the aerosols tab, and again, you have projects listed in alphabetical order, and you can click on any of those links to get to any one of those projects. Down the left-hand side of our window, you'll see our featured products. These are just the most popular used and the most used projects. You'll notice tests, which we'll be coming back to later. Also, other projects that we support, Air Misties down there in the special category, My NASA Data and SSE. I'm being coached from behind. Hold on a second. That's as maximized as it's going to get. Excuse me, I had someone telling me something from behind. I apologize. Let's go to the test. Let's go to the test project. Tests measures things like ozone, water vapor, carbon monoxide, methane, nitrogen dioxide, nitric acid. It has global observations and also some special project observations. If you look down over to the far right, there's that little rectangular icon. If you click on that, that will take you directly to the test science team website, which is separate from NASA. Separate from the ASDC. Down at the bottom, if you look across, there's Level 3, Level 2, Level 1B, and Documentation tabs. The different levels, what that means, in our software here, in our data here at the ASDC, It is processed on different levels with more or less processing depending upon the level. There is a level 0, which is basically direct from the instruments. You won't see that here. That is only really for the science team use. But you will typically might see level 1 data, which has the minimal amount of processing. Level 2 data typically has the amount of processing that would be needed for most of the analysis that most scientists would want. And then level 3 data, which is typically gridded data or data that has some extra processing beyond the level 2. Some projects have level 4 data, but that is not that common right now. Let's take a look at the level 2 products. Again, down here, Global Survey Standard or Special Observations. If I click on the Global Survey Standard, I'll get a list up of the various products that are available. If you look to the right, you'll see a little name like TL2CH4N. That's a short ISDS name. There's also a long name that goes with this product. You see you got the spatial resolution and temporal coverage available to see. I'll click on the product, the methane product. That takes me to another page, and this is what I typically would call the ordering data page, because up here at the top it has Reverb, which is a data download program. It's a data search and download program, but it is outside of the ASDC. It is more earth science data wide. It can order data from multiple DAACs. Below the order data button, there's a test order tool. It's a subsetter. We'll talk more about subsetters in a minute. But let's go back down here on the tabs down below at the bottom. There's the parameters tab, which gives you the main parameters from this product. Order data tab, which gives you more ways to order data. There's Reverb, again, which is controlled outside of the ASDC. There's something called data pool, which is data that we have available on disk that you can access directly. OpenDAP is also available to direct access, and it allows you to download data excuse me, and change the format, pick some of your parameters, and that brings us back to the test order tool, which is a subsetter. So let's go ahead and go to the test order tool. So step 1, select the test data product. Now we had picked level 2 ammonia, or we could come in here and let's say, well, I don't really want that, I want methane. You can select methane. You can choose parameters that you would like to see. I'm just going to go ahead and add all. Over to the right, you'll have a list of everything that's going to be coming out in your data files that you get from us. Step 2 would be to pick some calendar dates, your temporal range. So let me do that. And step 3, pick your geospatial range. You can type in your, your latitudes and longitudes on the left in the little boxes, or you can draw a little rubber band box. And that will put in your lat-long boundaries. Now, I'd like to talk a little bit about subsetting here. Without a subsetter, if you have this little rectangular bounding box, it's going to search for any data points that would fall within that bounding box. But let's say one of your data points is associated with a file that may have 10,000 data points in it. Without subsetting, you will get those 10,000 points in addition, or 9,999 points in addition to the 1 point that you really wanted. With a subsetter, it allows you to carve out just the data points that you want. Not every subsetter does exactly the same thing. Some subsetters also let you change the data format from HDF to some other format. Some allow you to put in X and Y's. Maybe you don't have X and Y's, you have lat longs. They allow you to add and delete more things to the file. But one of the basic uses of the subsetter is to get out just the data points that you want. Okay, so if you look at the lower left, it has 218 files. found. That was the initial search. And if you look really quickly down below, it's kind of grayed out now. It really found 29 files that fell within my bounding box. Here it selected those files, and it gives me a little recap at the top, the temporal constraints, spatial constraints, and my 29 files already selected. Well, I don't need all 29 of these, so I'll deselect them, and I'll pick 4 or 5 to actually order. I can have it come out in, excuse me, HDF or NetCDF. You can download an ASCII file listing. But, oh, and I'd like to note I'd like you to note that at the bottom you have links to test information, our homepage, test frequently asked questions, and the questions, comments, or feedback, you can actually send an email to us here at the ASDC to our user services group. So let's submit a request. And the request was submitted. You can log out, start another request, or exit. What will happen now, you'll get the first email of 2 will tell you, excuse me, it'll recap the data you ordered and your constraints. The second email that you will receive will tell you your data order has been completed, and it will give you directions as to where you can go to download your data and how to download your data. So we've ordered some data. What will we do next? Well, I want to look at my data, and let me just show you quickly something. There's the HDF group, which I mentioned before. The HDF group has some, excuse me, has some pre-made, excuse me, programs where you can look at the data and create various visualizations. So these are written, for example, for tests. They have a couple written in NCL programming language, MATLAB, IDL. They have several different sets. Moffett has some too, Miser, and Series. So I'm going back. This is at the HDF website, and we can provide you with that link. But you can see at the other data centers, you have that available. I'd like to show you HDF View, which is one of the tools that was available at one of those first tabs that we went to pull down. So here's HDF View. This can be downloaded from the HDF group. And this is a simple way of looking at your data. If I go to File and Open, I'll pick one of these 2 test data sets that we ordered. Excuse me again. And you can open up these little bundles here. Finally get down to data fields. Here's my methane. And I've got my data up, and it's like, oh, wow, it's all 9s. What's wrong with this? If you look down at the bottom, this is some metadata information. Missing value is a -999. But I go, well, wow, I don't see anything here. Where's the data? One thing that you can do, there's a table option, and you can do a show statistics. And there you can see the minimum is -999, but it gives you maximum and mean values and standard deviations. So I do see that there are other data points there, and I'm relieved. But let me scroll over and see if I can see, oh, okay, so there's my data, and now I see my data points. So this is a really quick and easy way to actually look at your data points, see where they are, and get an idea that, yes, you've got data there, and what some of the numbers are actually look like. There's another program I'd like to show you, and that, excuse me, is Panoply. Again, I can go up, open a file. Let's take that, methane file again. And here in Panoply, you have an option to list only the plottable variables. If you look over to the right, this is the metadata for this file. And if we want to go to grids, Panoply is a program that was developed at the Goddard Institute of Space Studies. And it's easy to load. It's easily available. So here's my methane parameter. It's telling me I have more than one type of plot can be created. I'll just go ahead and say create a plot. And there's my methane. Also, if you click on Array 1, you can see your data points here as well. Although I don't like the way that I prefer the way HDF View plots out your data points because it uses the extremes in the program to do it and get a better range. Okay. Now, from here, you can export data as a CDLs or CDF as labeled text, so you can export your data from here if you wanted to. Let's go back to create a plot. And now I can export a KMZ file, which is a file that you can look at, excuse me, on, Google Earth. Let's replace one that was already there. Okay. I want to go to My NASA Data. Let's say you're a new beginner. I guess every beginner would be new, wouldn't they? Okay. So let's go to My NASA Data. This is a good program, a good website actually. And it's great for new users. It has data that's available for anywhere from students through researchers. We're going to go to the live access server, the advanced mode. We can pick a data set up at the top left. You've got the different categories here. I'm going to pick atmosphere. I'll pick aerosol, monthly aerosol optical depth. And if you'll notice, I have information from more than one of our projects. I've got information from MISR and Calypso. Let me just pick MISR. And this is actually the MISR data right there. It gives you some information about your data set. This little box up here. Let's get rid of that. And I'll say, that's great. Now I want to see that on Google Earth. So I can click on Google Earth. Just take all the defaults. And we'll open that information with Google Earth. So there we go. That's a really quick way to visualize data and give maybe an overview of the data that you might want. And I believe that is pretty much it for me. So I will hand things back over to Jennifer.
Okay, so we do have just a few more slides regarding some future development that's going on at the Langley Data Center.
Oh, that's right. Yes, sorry. In the future, well, we're working on them now, but these are for future release, for release in the future. Sorry. Odysseys, which is a way of a new way of trying to input your queries and find data that you're interested in, and it cuts across boundaries of various disciplines, and it takes kind of normal human speak and searches data for you. ArcGIS, NASA's partnering with ArcGIS to bring more options for use in geospatial programs. iRods is a way of streamlining the way data is accessed here at the ASDC. And most importantly, contact us. So this is our website and then our email. User support at support-asdc@earthdata.nasa.gov. And that does conclude my portion.
Okay, so thank you everybody. We'll now move to the final set of polling questions. I would like to give these questions, a couple minutes or so, and after that we'll move directly to the question and answer portion of this webinar. So be sure to stay in the room and or stay on the line to participate in the question and answer period. So thanks very much. Let's give this a couple minutes. Okay, we'll give the polling questions just another minute or so, and we'll move directly to the question and answer period. Okay, everybody, we are going to move to the question and answer period now. And as I mentioned earlier, this webinar has been recorded, and I will post the webinar by Friday of this week to the tinyurl.com/earthdatawebinar. And we also do have a NASA Earthdata Facebook account as well as a Twitter account if you're interested in connecting with us in that way. And basically these accounts cut across all 12 of the data centers. In fact, at the tinyurl.com site, you will find in the catalog, you will find previously recorded webinars as well. So let's go ahead and see what we've got going on for questions. I'm just scrolling down here to see whether or not I can see any questions. At first glance, I didn't notice any. Don't be shy. Any questions for our speakers? Let's see, I'm looking down, and so far, I'm not seeing any. One of the participants earlier had mentioned sharing the animation with you, so what I will probably do is go ahead and upload the animation that was shown earlier within the webinar into this file sharing pod, and I should point out in the lower right-hand corner of your screen, this feature will persist, so you can download the presentation files both in PDF format and PowerPoint here, as well as the agenda and the contact information, not only today, but if you were to listen to the webinar at a later point, you would also have this information. Okay, here's our first question. Fantastic. So the first question is, I would like to know how to get more specific information, or say a microclimate area in particular, because it appears that the information is global. And so this individual only needs specific information, and he's saying that it appears that the information is only global. So Mary Jane or Michelle, do you have anything to add to that in answering this individual's questions?
Well, there's two parts to that. One is he might need a smaller area which you can use a subsetter, but I think the other portion he might be talking about is that our spacing might be too, the resolution is not fine enough for what he needs. Some of that is instrument limitation typically. So we may not be able to do anything about that, because the only way to get a finer resolution would be to do regridding, which is not always the most valid thing to do. Yeah, I guess that would be it.
Okay. Thank you, Mary Jane. And the next question is, this individual is looking for MODIS atmospheric data, but does not find it for African countries. And the primary issue here is that the MODIS atmospheric data, Mamoon, is not available through the Langley Data Center. There's actually a MODAPS data center here at Goddard Space Flight Center, and I can touch base with you offline for that and send you some links for retrieving MODIS data and working with it. Okay? So what I'll do is I will touch base with you offline when this is finished. So that's the primary issue, and we can discuss what specific atmospheric data you're looking for, what questions you're trying to answer. Okay, so then the next question is, how can we get quality control information about the data we download? If there's anyone else in the room from Langley DAAC who would prefer to answer the question, just go ahead and speak up. Or Mary Jane, whoever would like to answer the question.
Well, we have, on our website, we have, under documentation, if you go to the landing page of the project that you're interested in, and even if you select the data set that you're interested in, if you look under documentation, you'll find documents like the product specification, which is more about how it's organized. There's the algorithms, which will tell you how the data was basically, the number crunching behind the data. And then the other one is the quality summaries, which tell you about any problems and how they, any problems with the data, or the quality limits. What do you call that? Well, it tells you the thresholds, the quality thresholds for the data. So we have documentation, and it's on our website. It's under the project. So there's the quality summaries, the product specifications, the algorithms, those three documents.
Okay, so does this answer your question? The user wants to type into the...
And if there are questions that we can't answer from those, that aren't answered in those documents, we can contact the science team and get answers from them if necessary.
That sounds fantastic. Thank you, Mary Jane. So the next question is from Tom. What other tool besides HDF View was it that Mary Jane used to look at the data? Now, I typed in Panoply, but you may want to speak to that.
Yeah, I typically call it Panoply. It's by Goddard Space Institute, and Panoply. If you will Google NASA space Panoply, Panoply, it'll take you to the Panoply page, and if I had it up here, I could actually show you that. But so just Google NASA and Panoply, Panoply. It'll take you to the homepage for Panoply, and you can download it very easily.
Okay, that sounds good. And the other thing I think that we could do actually, Tom, is I can, create another, one-pager with any additional URLs that may have been mentioned within the Q&A portion, but not necessarily within the PowerPoint, and easily upload that to, to the webinar presentation files. Or I can email you the URL as well afterward, because I do have, the registrant's email addresses, so I can certainly follow up in that way as well. Any further questions from anybody? Let's make sure okay.
Also, if I could just add something, any of these questions you've already asked or something you think about, just send us an email to the support-ASDC@earthdata.nasa.gov. It'll create a ticket, and we can track it and answer it. So please contact us. You can call us as well.
And this is the URL here, support-ASDC@earthdata.nasa.gov.
Correct.
There you are. I've typed that in for everybody. Any further questions? No burning questions about using the Langley DAAC data sets?
I noticed someone was speaking before on one of these panels I see up here that they were talking about if they're able to download data using a script. From Data Pool, you can do something like that. That's it.
And the data pool is linked from the Langley DAAC homepage as well.
Right. Now, today we're undergoing some maintenance, so it's not available today, or I would have shown it to you. But it is available all the other days.
Yeah. It's lovely to have it.
Okay. So are there any other questions? Okay, well, so I will actually leave the room open for about 10 more minutes or so. If anybody has any questions, if you want to stick around, you can feel free to type in your question at that time. Our next webinar will be held on, let's see here, May 28th, and we will actually feature our Crustal Dynamic Data and Information System data center. So there'll be an overview for not only the website, their new website, but also the type of data that they have available, more focused on those who are in the space geodesy field, and also other land processes or geology-oriented fields. So we will have that coming up in May. All right, well, I thank everybody. If there are no further questions, and I'll take one last round, one last look here, then I will go ahead and log off from the telecon in a moment or two, and we'll leave the room open. If you have any questions, we'll still be here. All right, so let's take one last look. And I don't think I've got anything else. I thank everybody for joining us today. It looks like that will wrap it up. Thanks, everybody. Bye-bye now.
Bye.
The conference is now in talk mode.
All right, bye-bye, everybody. Thanks.
Bye-bye.